Tushar, it's handed over to you. Tushar, can you hear me?
Yeah. Hi. Yeah. Can you guys hear me properly? Can you guys hear me? Yeah.
Yes, we can.
All right. I have to ask somebody at there so that they can go to the next slides depending on how long I take on the slides, because I cannot control slides from here.
He can control the slides?
So once I finish up my slides, I'm going to say, okay, next slide. Okay. All right. My name is Tushar Dave. I work for Oracle, and today I'm going to talk about using eBPF for RDS filtering. The agenda looks like, I'm going to give a little bit brief about what is RDS. I know that, some of may probably know more about RDS, some of probably don't have any idea about RDS. So I'm going to go a little bit brief so that, it set the tone so that I can talk about the problem that we are trying to solve. I'll talk about the solution that we considered and the solution that we actually, took as a POC and implemented some of the code as an RFC sent to Netdev. And then I definitely leave a couple of minutes of room for Q&A. Next slide, please. Okay, so RDS stands for Reliable Datagram Socket. From the layman's term, think about this as a reliable UDP. However, this basically provides RDS is being used highly in Oracle rapid application clusters, where each node in the cluster basically runs different DBMS RDOS applications. This is a high performance reliable connectionless protocol which basically provides in-delivery datagrams. Think of RDS as it's a transport layer protocol, but it basically sits on top of TCP and IB. So it can work with the Ethernet channel, which basically the packet arrives in and goes through the regular Ethernet stack, TCP/IP stack, or it can work with the InfiniBand channel as well, where the packet is basically go through RDMA or IB stack. From the user space perspective, so this is a typical client server model. Client basically open up a socket which is of domain PF RDS. But client also has to set the transport, because we deal with two kind of transport, and just bind the local address and use the local just a regular send message and receive message system call to communicate with the server. Next slide, please. All right. So how does it look like from the architecture overview? So you can see that on the left side, as I told, we have two kind of transport. One is Ethernet. So we basically, off of the TCP, we have a module called RDS TCP that deals with anything that comes off the TCP/IP stack. And eventually, once the packet is arrived at the RDS TCP, we have a transport independent layer module called RDS core, which basically eventually take the packet and does all the communication with the user space. Same happen when we have InfiniBand as IB as a channel. However, the packet goes through IB RDMA stack. We have RDS RDMA models. We have two different transport modules, right, on top of the transport. We have RDS TCP, we have RDS RDMA. Eventually, they both talk to the transport independent layer module called RDS core, which basically does all the talk and the transfer between the RDS application which runs into the user space. The point that I want to make here is, on the left, when we have Ethernet and TCP/IP stack, we have packet which is contained in a SKB, which is a regular SK bar. However, when we deal with the InfiniBand channel and packet arrives, we have is a scatterlist. We don't have any other form, but just a regular general scatterlist structure. So we have to deal with both kind of things, and I'll talk about more that. Okay, this whole talk is based on this two different kind of form of structures that we have to deal with when we have to deal with the packet filtering or any kind of deep packet inspection. Next, please. Thank you. All right. So, what problem we are trying to solve? We are trying to implement, a filtering kind of solution for RDS at the RDS core layer, right, which is independent of the transport, where we have two kind of, structure to deal with. What we want to do is for the rapid application cluster folks is we want to look and identify, we want to do deep packet inspection for every RDS message that we receive at the RDS core. And if the message is being identified as, okay, it belongs to a certain database service, we want to basically pass that message directly to that database service. If the message is not identified as one of the, candidate for the database service, which is running on the node, we might probably need to, change the RDS header, and probably forward that packet to the another node which runs the database service. Or we might just need to drop the packet because that packet, it's not important at all. So, just a regular kind of, actions that we have to take. The point is we have to look at the RDS header as well as RDS payload, because RDS payload, it basically gives us an idea if it belongs to a certain kind of service or not. So looking at this, do we have any unified filtering solution that we can use today for RDS TCP or InfiniBand? We look around and what we figured is, next slide. What we figured is there is something netfilter. I mean, that comes to first our mind. We looked at over it, and we can use it today for RDS TCP. However, in our experiment, it looks like we cannot use it for RDS InfiniBand because the major disadvantage for netfilter is it only deals with skbs, and we don't have skbs, and we have everything that comes or IB or InfiniBand. So we look around and we find another alternatives, and the second alternative is, next slide please. The alternative that we find is eBPF. Now, eBPF is being adopted, growing rapidly. A lot of things have been implemented, being used for socket filtering, TC. We have solution for XDP and whatnot. So when I look around personally and I look for, okay, what if eBPF can be a fit for RDS? Two things that come to my mind and that I want to point out here is, we have a very strong, infrastructure for eBPF right now in netcore-filter.c. Very easy to understand as far as, newbie as eBPF when I went in a few months back. And the best part is sample BPF. We have a sample BPF and there are tons of examples there. So, trying to implement something as a POC to see that if that fits our need or not, that eBPF solution, what we have in the kernel existed, it feels more feasible that, okay, we should try this with what we are trying to solve. The other, I mean, just looking over and, jotting down the notes and bullet items, we also find that there is a side advantage. If we choose BPF for the filtering, we can use it for RDS observability or I would say debugging. And just to point out, as an example, there are multiple things we can do as a debugging. But, today we don't have anything like, for TCP IP, when we receive traffic over Ethernet channel, if we run TCP dump on RDS packet, which is for, intended for RDS TCP module, it's hard to parse the message because, RDS message does not, because of the TCP stream nature, it does not preserve the message boundaries. So, I mean, just write simple POC, we could dump the RDS packet completely with the header and the payload. So, all in all, eBPF seems like a win, and I pursue with that. And then what I have done, next slide. Okay, so what I've done, how does this going to fit my, because RDS is a type of socket, so before I go into that, eBPF has a lot of different kind of program available right now. If you look at just a netfilter.c file or even the sample BPF, the BPF libraries that we have, you can see that we have programs type for socket filter, we have program types for TC, we have for sock map, we have C groups and all that. Because RDS is a type of socket, I think it closely resembles to what I try to do with RDS, with the socket filtering. We already have socket filtering, which we have infrastructure in there, but the problem is it only deals with skb. So, for me, I try to fit my needs so that, I can deal with the scatter list and somehow, make this available for RDS. However, the existing socket filter or traditional socket filter that we have, I could use the infrastructure, but I could not use as it is. So that needs, basically, I get to the point where I think of okay, the socket filtering, if the RDS is a socket, but I need to implement something which deals with scatterlist. So I added a new BPF program type called BPF probe type socket SG filter, which is similar to traditional socket filter, except that instead of skbuf, it's going to get it BPF scatterlist, or like, I would say scatterlist as a BPF context. I can use the same load and attach kind of, method for BPF SG filter as well, which is like, using the set socket option. And only thing that I need to adjust it here is, sample BPF, because I intend to use the sample BPF as BPF libraries, infrastructure, and all that. So all I did was I added a new program type so that my library can, recognize my program. Like for traditional socket filter, you basically provide SAC socket. In here, I added new type or new naming convention, which is called sock SG. So next. Okay. So after adding infrastructure, there's a lot there already. I need to adjust my new program type and so that it can receive the scatter list as a context. Now, looking at why did I choose scatterlist? So looking at SKB and scatterlist closely, it feels like to fit our need, scatterlist is the common denominator between because SKB itself has scatterlist inside, the SK flag and all that. So both of structure, we feel like, okay, if we define a solution for that deals with scatterlist, we can use it for RDS. After infrastructure, what else is remaining? So, today, if you have traditional socket filter, we have function calls. If you look at the filter.c file, we have skb trim function call, which basically, take the skb, does whatever it is, take the RCU, eventually find that, okay, do we have a socket filter program attached or not? And eventually it's called BPF program. For my need, what I need is any kernel entity that want to deal with scatter list. And for example, we have to deal with RDS. I added a new function called SG filter run. And what this function does is basically, similar to traditional socket filter, this basically passes the scatter gather list. And, the point that I want to make is I added a new kernel level structure. It's called BPF scatter list. And that structure basically has a scatter list that we want to deal with. It basically deals with each element of the scatter list. So I have to make sure that which element I am, because the first time I call that structure, it basically passed the pointer to the first SG element to the BPF program. So that's the reason I have current SG, which points to the current index into the SG list. I have number of SG element inside, and the start and end is basically, points to my beginning of the packet in my fragment of the packet in the first entry of the scatter gather list. So when this function is being invoked, it basically checks if any BPF program is attached or not, sets up the initial data structure, which is in-kernel data structure used only by the BPF, which deals with the scatter list, which is BPF scatter list. And at the end, it basically calls, the regular BPF program run, which eventually, if the program is attached, then the kernel BPF program is going to get invoked, and then, we basically pass the scatter list right here. So next. Okay. So what else I need? So we have infrastructure added. I added the infrastructure, that basically deals with that. I added the function call that the kernel module has to invoke to actually run the BPF program that deal with the scatter list. I need something which is similar to what we have today. We have for skbuf, we have underscore skbuf, or I would say, the user visible structure that basically, BPF program can access. I added a similar structure for SG filter MD, and all that I need is data and data end. So for whatever SG element I am in, it will basically just point me. So the start and end pointer eventually get exposed to the user space through data and data end from the BPF scatter list structure. However, there is something extra that I need. And as a POC, I'll talk about this later, but as a proof of concept, what I have done is, as I told you, when the first time the program is being invoked, it only gives you the first scatter list entry. Somehow I need a mechanism so that I can retrieve or walk through the SG list, or the scatter list elements. So for that, as a proof of concept, I added something called, BPF SG next, which is a BPF helper. And all that does, if you look at here, is when this function is being called from the BPF context or BPF program, it will increment the current SG, which basically allows me to point to the next SG index or SG element into the SG list. And then it will fit in all the start and end pointer and eventually return and then my BPF program now can access, remaining element or the next element in the SG list. So with these three pieces all together to fit in, I try to implement something in the sample BPF. And next slide. Okay, so you can see that this is sample user program, and like a traditional socket filter, what it does, it basically open up a socket, and you can see that it's on the very top. It opens up PF RDS domain. It checks. It basically sets the transport, because we have two kind of transport. So it sets either TCP or InfiniBand as a transport. Sets up the socket address structure, bind the socket, and eventually the last thing is it calls set socket option. So the attachment point of view and setting up things, it's like similar client server model. I'm not doing anything extra in here. Only thing I'm doing it, okay, it basically uses the same SO attach option, as SO attach BPF, which basically allows me to connect, attach my, using the existing socket filter infrastructure. It allows me to connect my BPF program. So next slide. So with that, my user program is done. All that I need is all I needed was just make the set socket option. There's no chain needed. The chain that I need in the sample BPF program is, you can see that on the top, on the right bottom corner, I identified the program as the sec sock sg, which basically, as I told you in the 3 slides back, that when I added the infrastructure and massaged a little bit the sample BPF, I added sock sg as to identified as the program that deals that going to receive scatter gather as a BPF context. That context that eventually the structure is SG filter MD, which basically have data and data end pointer, like skbs has beginning data and data end. All that I have is in this POC is it basically dumps few bytes from the scatter list, whichever entity is pointing. I need to walk through, and I cannot use loop. So what I have done is I basically have BPF tail call here, which I know that it has a limit of 32 nested call. But for what I'm trying to show as a POC, or do as a proof of concept, I think that should be enough. So this BPF next BPF tail call is being added, and you can see that what SG dispatcher is being calling. It basically calls the BPF SG next, which basically gives me the increment the SG list index to the next SG element, and then I call BPF tail call, which eventually calls the prog SG1, and I can dump my packet. So this is a very basic proof of concept. Going in the future, of course, I don't want to walk through the SG list. And today for even SKB, we don't walk through the, if you have multiple fragments in the SKB, we don't walk through that. I want something like, okay, here is my scatter list and here's my offset. Go figure it out. And I want to do similar thing for the scatter list, so that all we need to do is we need to pull certain bytes. We need to look at the packet, and then we need to take certain action. So, but as a POC, the infrastructure work and the basic stuff is done. Next. All right. So having eBPF infrastructure, sample BPF program, and POC done, of course, I need to make certain adjustment into RDS as well. However, in my experience, we have to do very little less modification into RDS. The point that I want to make is, because of the two transport, and where we have RDS TCP and RDS, RDM as a module. For RDS TCP, of course, we need to convert SKB before we give it to the scatter list. So we use existing kernel function SKB to SGBAC, which basically, does the job, and we give us the scatter list, and we basically feed it to the kernel program. Besides that, you can see that there is only a couple of line of changes, and as you can see that any kernel entity that wants to filter out program based off scatter gather list, they have to run SG filter run, and that function is, I showed in the previous slide. It basically does the job, sets up the context, call the function, call the BPF program, and through BPF program you can handle and you can look into the packet like what we do with skbs. Next. So with that, what are the next steps? So I want to first thank John Festaben and Daniel Bokerman for looking at my RFC and giving me valuable feedback. This RFC is being sent probably about 2 weeks back or a couple of days back. The suggestion that came from Daniel is, that I'm using set socket option SO attach BPF for RDS today. However, if we look closely with the design that I have or the infrastructure that I try to use as a traditional socket filter, somebody can attach non-RDS socket, which is regular TCP or UDP socket, and they can get the they can always get skbs as a context, while they can get the program is expecting scatterlist. So there is a potential chance here that this can harm the kernel. So the advice that I got is I should make this more kind of like RDS specific to begin with, and then look for the more detailed option. So I'm working on that. The second thing was, there is something other than sock SG that today deals with scatterlist, and which is there in the BPF, and that is sock map. Sock map actually also deals with scatterlist because it basically deals with TLS, transport layer security protocols, and where the context is scatterlist. So we have some code, we have some filters. We have some BPF helpers as well. So I've been told that, okay, if I could just try to reuse the code as much as possible, which is the only thing that I have is BPF, some structures and BPF helper, then that would make it more fit into the kernel as well, so that we could reuse and we could share the helper as well. And of course, because this was POC, I didn't send any, I didn't have any action code like pass, forward, or drop the packet like we have it for XDP or something like that. So definitely I'm going to add those codes, and the intention is that function once your kernel program looks into this, the RDS kernel program, BPF program looks into the scatter list, identify the message where it belongs, probably mingle with the payload or mingle with the RDS header, change as necessary, give it back to the RDS core module where the XN code is being passed, and RDS core module eventually either send it to upstream, send it to re-inject it to user space, the regular path, forward it to another rack node, or just drop the packet. Next. All right. So future work. In the previous slide, I said that I got an advice that I should make this more RDS specific, especially for the attach option. I would do that. However, I'm still finding alternatives and solutions so that we could make this more available, like more generic for other socket types as well. Who, if anybody wants to use, don't have SKB and they want to use scatterlist, they can use this. So I'm working on that. The other thing is, eventually I want to use a sample BPF similar construct so that we can provide a kind of, small library. If sample BPF can work out, that would be great. If it doesn't work out for what we want for database, and this is more for internal, but I want to build some certain constructs so that it is easy from the user space or from administrative perspective, so that we can write rules or some kind of script from the user space where we can specify what is our intention, what we want to filter out, how we want to take certain actions. So that's for the future work. Next. And I basically need a couple of minutes for the questions. Thank you.
Any questions? Nobody? So I'm going to ask a question.
Sure, go ahead.
Is there an echo? Yeah, so what you're suggesting is, so eBPF currently is missing scattergather, is that right? Did I understand that correctly? And
yes.
Because it doesn't use a proper SKB, its own variant of what an SKB is, yes?
Anything that we have is mostly deal with SKB, except that one point that one other example that I said is sock SG, but that is completely based off the C groups and the way it fits in, and it deals with the sock map. We don't want, and if I go on that route, that makes it more complex, and it doesn't fit the need that we need for RDS. For RDS we need pretty simple thing, and being a socket, we want something like I think socket filter would completely fit the need, and we could do the job without adding much changes. Because of the eBPF, we have to add a new program type so that it's being identified. And other than that, of course, I mean, I could use reuse the BPF filters, which is there, which deals with scatter list, but the core infrastructure is not there. That the BPF context is being passed as a scatter list.
Okay, Fulvio, you have any comment on that? You didn't have to deal with scatter gather. Yeah. I guess, what's the status? You submitted these patches, yes? Or you label them as POC, you're not submitting them, or are you planning to? Or?
No. I mentioned this as a POC when I begin the work, but when I send my version 2 as an RFC, which is out, that is being reviewed, and my intention is to, I was just waiting for this one so I get some feedback. And definitely I got some feedback from the community by email as well. But I want to just deliver my talk, and then, from tomorrow I'm going to work on making RFC as V3 and do the suggested changes and, make it into the kernel. That's the intention.
Okay, thanks. Nobody else has comments? We can let Tushar go. Thanks, our first remote speaker ever. Thank you.
Thank you so much, Netdev. Thank you.